Welcome to this explainer. Look, if you're involved in specifying, purchasing, or installing cable management systems, you already know the harsh reality. Getting your dimensions wrong on paper translates into absolute chaos on the job site, literally the kind of stuff that gives project managers gray hair. So today, we're unpacking a master checklist for 2026. We're going to break down exactly how to lock in your width, depth, and span, and ultimately, how to dodge those incredibly costly mid-construction disasters. Here is our roadmap for today. 1. The mid-construction tray disaster. 2. The hidden deflection danger. 3. The 5-step sizing workflow. 4. Navigating geometry and clearances. 5. The 2026 buyer verification checklist. And finally 6. How Xinma is meeting global standards. Let's jump right in. Section 1. The mid-construction tray disaster. So you have a perfect design on paper, right? But the second it meets the physical build, your assumptions get put to the ultimate test. The absolute most crucial thing to remember here is that width, side height, and support span are inextricably linked. You literally can't isolate them. Think of them like interconnected gears. Turning one immediately forces the others to move. If you alter your width, it immediately impacts your side height and span requirements. Getting just one of these right while ignoring the other two is exactly how deflection, fill capacity, and load class problems just explode out of nowhere mid-construction. If you order the right width for your cables, but totally fail to correlate it with the support span, the whole structural integrity is compromised. You got to treat these three as a single unified system. Section 2. The hidden deflection danger. Now, this is where common sense can actually lead you straight into a trap. Ask yourself this: what happens to deflection when you increase your support span from 2.0 meters to 3.0 meters, keeping the load exactly the same? When constraints force a change on site, folks try to do quick mental math. You're going from 2 to 3 meters, which is a 50% increase in length, right? So you'd naturally assume that the deflection, that sagging of the tray under all those cables, probably just increases by about 50% too. Let's look at why that assumption is a total nightmare. Buyers, and honestly even some engineers, assume it's just a simple 50% bump. But the cold, hard engineering reality, it is way, way more severe. The actual deflection doesn't just scale up a little bit, it multiplies geometrically. We aren't talking about a slight tag, we're talking about a massive structural deviation that can bring the whole system down. 3.4 times. The deflection completely explodes by a 3.4 multiplier, just by making that simple jump from a 2-meter to a 3-meter span. It's wild, right? This one number proves exactly why you must check the interconnected math before you buy. If you buy a tray rated for a 2-meter span and your installers stretch it out to 3 meters just to dodge an HVAC duct, the system doesn't just bend, it structurally fails. Section 3. The 5-step sizing workflow. To solve this, we need a rigorous workflow that stops that 3.4 multiplier from ever catching you off guard. This workflow takes you systematically from design straight through to procurement. Step 1, you always begin by assessing the cable schedule so you know exactly what is going into that tray. From there, step 2, you execute the sizing workflow based on that specific fill. This lets you securely lock in step 3, confirming your trade width to prevent overheating. Then immediately on to step 4, confirming your side height for structural rigidity. And only then do you hit step 5, confirming the support span. If you follow this process, you're finally treating width, height, and span as the linked variables they actually are. Section 4. Navigating geometry and clearances. But hey, the math and the cable schedules are only half the battle. The physical building environment throws a massive wrench into everything. What looks totally fine on a 2D drawing might completely fail in 3D space. Route-specific variables, specifically fittings, clearances, and building geometry, can completely alter your correct dimension on site. You might have calculated the absolute perfect straight-run width, but the second you introduce directional changes with fittings, or you hit tight ceiling clearances, or run into complex building geometry, like unexpected support columns, your baseline dimensions have to pivot. The correct dimension is highly localized. You have to verify that your selected tray actually fits the physical route, not just the math. Section 5. The 2026 Buyer Verification Checklist. Let's transition to the practical, concrete tool you need for the upcoming year to keep all this straight. Before you sign off on any procurement, you have to rigorously verify 4 specific items. 1. Your drawings must accurately reflect the real-world geometry and clearances we just talked about. 2. Your load tables. This is where you catch that 3.4 deflection multiplier by matching the certified capacity to your intended span. 3. Don't forget your accessories. Fittings, covers, and splices are essential for the system to actually work. And 4. Ensure your export documentation proves compliance for your destination. Do not issue that purchase order until all 4 are verified. Section 6. Xinma, meeting global standards. Finally, let's look at how a top-tier manufacturer actually aligns with these crazy demanding requirements on a global scale. Shanghai Xinma Busway and Cable Tray Company, or just Xinma, manufactures comprehensive systems designed for these exact challenges. Their portfolio includes complete cable tray systems, busway, seismic bracing, and intelligent cable management solutions. When you're dealing with complex variables like massive deflection multipliers, you cannot afford a piecemeal mix-and-match approach. You need a manufacturer like Xinma that engineers systems holistically, rather than just selling standalone parts. And that holistic approach translates directly into global compliance across some seriously demanding industries. If you're building data centers, their products comply with IEC 61537. For rail transit, they meet NEMA VE1. Industrial plants are covered under BSEN 50085, and commercial buildings align with GB 31251. This isn't just alphabet soup, folks. These standards dictate the strict testing protocols for load, span, and deflection. By adhering to these, manufacturers like Xinma provide the certified load tables you need for your buyer checklist, giving you total confidence that the structural math holds up in reality. I want to leave you with this provocative thought as you audit your own upcoming projects. Ask yourself right now, does your current procurement process rigorously check that 3.4 times deflection multiplier before the order is placed? Or are you just kind of assuming a 50% bump and crossing your fingers? Use this 2026 master checklist, apply the 5-step workflow, respect how width, height, and span are deeply connected, and make sure you aren't walking blind into a completely avoidable mid-construction disaster. Thanks for joining me on this explainer, and I'll see you on the next one.